Okay. So in this session, so we are going to discuss about the engine performance parameters. So we are going to solve some simple problems related to the IC engine, the internal combustion engine. Before solving the problem, we should know the various formulas that is required for us for the calculation. So today we are going to discuss the formulas as well as we are going to try to solve 2 to 3 problems. So that is my objective of this class. Okay. So the first is piston speed. So this formula has already been given, right? What is piston speed? Average speed of a piston. So that we are going to call as piston speed. So that is given by the formula Vp is equal to 2 L N divided by 60. So the unit will be in meters per second. Okay, this is the first formula. So piston speed, average piston speed or piston speed is the average speed of a piston. So that is given by a formula Vp is equal to 2 Ln divided by 60. What the L stands for? Stroke length. L stands for stroke length in meters. And N stands for engine speed in RPM, rotations per minute. So units are very much important in the case of while solving the problems. So it is very much important. If you are not going to be careful about the units, you are going to end up with the wrong answers. Okay? So be careful about the units. So 2 Ln. L stands for stroke length. So that should be in what? Meters. And N is the engine speed or speed of a shaft. So that must be in RPM, rotations per minute. Okay, so this is the first formula. Second one. Okay, so next one is swept volume. Swept volume. So swept volume is Vs is equal to 5 by 4 P square into L. Okay, swept volume. Volume swept by the piston. So during the movement from top dead center to bottom dead center or bottom dead center to top dead center. So that is called as swept volume. It is represented as Vs. The formula is pi d square L by 4. What is the meaning of D? Bore. Okay, so bore means what? It is diameter of the cylinder. So that must be in meters. And what is L? L is already been given. What is that? Stroke length. Okay, so that must be also must be in meters. Okay, so what is the unit? Stroke volume. Meter cube. Right? Why meter cube? So here we have d square. Right? Into L. So therefore the unit is meter cube. Is it clear? So what is the unit here? Meter per second. So what is the definition of swept volume? The volume swept by the piston while moving from top dead center to bottom dead center or bottom dead center to top dead center. So that is called as swept volume and the formula is here. Is it clear? So next formula, indicated power. So that is called as IP, indicated power. Okay, so indicated power. The power It is defined as the power generated inside the cylinder due to the combustion of fuel. So that is called as what? Indicated power. I'll repeat once again. The definition of indicated power is, it is defined as the power developed inside the cylinder due to the combustion of fuel. So that is called as what? Indicated power. So that is given by the formula IP is equal to PM Vs N K N divided by 60 into 1000. Okay, so the unit of the indicated power will be kilowatts. Okay, so the unit of the indicated power is kilowatts. Is it clear? So indicated power is equal to PM Vs N K N divided by 60 into 1000. So what is the unit of indicated power? Kilowatts. What is the definition of indicated power? It is defined as the power generated inside the cylinder due to the combustion of fuel. So that is called as indicated power. So now the important thing is, what are the important factors over here? So the PM represents mean effective pressure. What is this? Mean effective pressure. So the unit of this will be Newton per meter. Okay, so mean effective pressure. Right. So the unit is Newton per meter. Okay. So PM represents the mean effective pressure. So it is given by the unit Newton per meter. What is Vs? Swept volume, or it is also called as stroke volume. Swept volume or stroke volume. So that is Vs. So that must be in what? Volume. It must be in meter cube. So what is the next thing? N. What is N? Engine speed in RPM. Okay. Next, what is a K? K is a constant. K is a constant. If the problem is on 4-stroke engine, the value of K will be equal to 1 by 2. Okay. So it's a K is a constant. K is equal to 1 by 2 when it is a 4-stroke engine, and K is equal to 1 when it is a 2-stroke engine. Is it clear? So this is about the indicated power. And what is the small n represents? Number of cylinders. Okay. So small n represents number of cylinders. Is it clear? So what is the formula? This is the indicated power. Next one, fourth one, BP. What is BP? Blood pressure. Boiling point. Super sir. It is a brake power. Anyway, you are going to reply. No, I am very happy for that. That's all. Okay, whatever makes the answer, don't worry. Even it is wrong or right, it's all next. But if you are responding, so that is well and good in the class. Okay. So next one is BP, that is called as what? Brake power. So what is IP? The power generated inside the cylinder. Okay, so that is called as indicated power. Whereas brake power means the power available at the crankshaft. It is defined as the power available at the crankshaft. So that is called as what? Brake power. Okay. So it is given by BP is equal to 2 pi NT divided by 60 into 1000. Okay, so this is the what? Definition of brake power. So the unit of BP will be kilowatts. What is N? engine speed in RPM. So T represents torque, so that must be Newton meter. Torque. Okay. So torque generated, so that it must be Newton meter. Okay. So you please make a note of this 4 definitions first. So then I am going to give you a break for 5 minutes. So write your notes. So then I am going to explain other 5 definitions. Is it clear? So I will repeat once again. What is the first one? It is the piston speed or average piston speed. It is the average speed of a piston. So it is called as piston speed. So it is given by 2 ln by 60. So why it is 60? We are dividing. So if you are going to substitute ln, it will be in meter per minute. So for our usually the standard procedure we need in a meter per second. So that's why we are going to divide it by 60. So next one is the swept volume. The volume swept by the piston while moving from top dead center to bottom dead center or bottom dead center to top dead center. The formula is pi d square L divided by 4. So here D represents what? Bore diameter or bore, cylinder diameter, that is called as bore. And L stands for stroke length. So both must be in meters. The unit of stroke volume will be meter cube. Okay. So next one, that is the indicated power. What is the definition of indicated power? Super, the power generated inside the cylinder due to the combustion of fuel. So that is called as indicated power. The formula for this is PM PS NKN divided by 60 into 1000. So don't get confused when you are going to refer in the sum of the textbook. The formula might be different. It is not different. The substitution of unit will be different. Okay. So in some textbook the formula was N Planck, N PM LA NK into 10 by 6. Okay. So but the substitution of the units will be different in that case. In that case, the pressure, mean effective pressure, has to be substituted in bars. Okay. In this formula, so what is the unit of mean effective pressure? It must be Newton per meter. Is it clear? These are the very important things. When you go and refer to the textbooks, no. So that is also right. This is also right. Only the substitution is different. The unit of substitution is different. Please be careful. If you are following my class, please follow this, because throughout the problem session I am using this formula. Is it clear? Okay. So mean effective pressure, that must be substituted in what? Newton per meter. Next, what is the VS? Stroke volume, that must be in meter cube. Next, what is N? Engine speed or piston speed in RPM. Next one, K. K is equal to, K is a constant. K is equal to 1 by 2 for four-stroke engine, and K is equal to 1 for two-stroke engine. And N, small n represents number of cylinders. Okay. So unit of IP will be kilowatts. So next one is brake power. What is brake power? It is defined as the power available at the crankshaft. Okay, so that is called as what? Brake power. It is given by 2 by N3 divided by 60 into 1000, where N stands for engine speed in RPM, T stands for torque, that must be Newton meter. Clear? Please take. Okay, so we discussed first set of formulas. So now another set of formulas. We have another 5 formulas that I need to discuss. So the fifth formula is FP. What is FP? Freezing point. Freezing point. So it is a friction power. Okay. So it is given by Fp is equal to Ip minus Vp. Easy along. So we know IP and we know BP. So difference of this is FP. That is the friction power. What is the meaning of this? See, IP means the power generated inside the cylinder due to the combustion of fuel. Okay. What is BP? The power available at the crank. See. So there is a difference between the power generated due to the fuel and the power available at the crankshaft. So the difference is the friction power. So that means some of the power is lost due to the friction. So friction of what? So the piston will be reciprocating. So that will be having a friction with the cylinder. And the connecting rods will be there, crank will be there. There are many connections are there, many movements are there. So some of the power will be lost due to the friction. So that is called as friction power. Is it clear? So what is the unit of FP? Kilowatt only, no? IP is also in kilowatt. BP is also in kilowatt. So the difference will be also in kilowatt. Is it clear? So this is the friction power. So next one, sixth one, specific fuel consumption. Okay, specific fuel consumption. It is defined as amount of fuel consumed per hour per unit power. Okay. Repeat once again. Amount of fuel consumed per hour. Okay. So amount of fuel consumed per hour per power. Per unit of power. Per unit of power. I will explain once again. It is defined as amount of fuel consumed per hour per unit power. So that is called as specific fuel consumption. So that is given by MF divided by BP. MF divided by BP. So what is the MF? Amount of fuel consumed. That will be kg per hour. Okay. The unit of the mass of fuel consumed, that must be in kg per hour. So what is this BP means? Brake power, that will be kilowatt. So what is the unit of specific fuel consumption? Kg by kilowatt hour. That is the unit of specific fuel consumption. So it is defined as the amount of fuel consumed per hour per unit power. Per unit power. So that is called as specific fuel consumption. It is going to tell you the fuel consumption by the engine. Okay. So the more fuel is consumed to develop the unit power. Okay, that means it is not fuel efficient. Okay, so these are some of the specifications that they are going to look into when they are going to select the engines or vehicles. Okay, what is this? Specific fuel consumption. Next one. What is that? Seventh one. Indicated thermal efficiency. Indicated thermal efficiency. Okay, it is given by, it is the ratio of mass of fuel consumed by, it is the ratio of IP by power developed. What is that? MF into CB. Indicated thermal efficiency. So that is into 3600. So this is the formula to find out the indicated thermal efficiency. So I is there, indicated power divided by power produced due to the combustion of fuel. That is called as indicated thermal efficiency. So what is IP? You know what is that? Indicated power in kilowatts. What is MF? Mass of fuel. Kg per hour. Okay. So this is the mass of fuel consumed. Kg per hour. Correct. Next. What is this? CV represents calorific value. Okay. So that is given by kilojoule per kg. Okay. So this is the indicated thermal efficiency. It is a ratio of indicated power to the power produced or power generated due to the combustion of fuel. So that is the indicated thermal efficiency. Is it clear? So this will be represented in terms of percentage. Okay. So indicated thermal efficiency will be represented in terms of percentage. So it is a efficiency, no? So efficiency usually it will be represented in terms of percentage. Is it clear? Okay. Next one. Brake thermal efficiency. So this is indicated thermal efficiency and this is the brake thermal efficiency that is given by, what is brake? Vp by mf into C into what? 3600. Okay. So Vp must be substituted in terms of kilowatts. MF must be substituted in terms of kg per hour. CV, that is the calorific value, that has to be substituted in kilojoule per kg. So it is a ratio of brake power to the power produced. It is similar to the previous one, that is the indicated. Here it is brake thermal efficiency, here it is the indicated thermal efficiency. So next one, unit, percentage. Okay, so the last is mechanical efficiency. So that is given by Vp by Ip into 100. So this is also represented in terms of percentage only. Mechanical efficiency. It is given by ratio of brake power to the indicated power. Is it clear? So these are the different formulas so that we are going to use while solving the problem. I will repeat once again from this. Okay, what is the fifth one? It is the frictional power. It is the difference of Ip minus Vp, that is indicated power minus brake power. So it is given by Ip is equal to Fp is equal to Ip minus Vp. So the power loss due to the friction. So next one, sixth one is the specific fuel consumption. What is the definition? It is the amount of fuel consumed per unit power. So that is the specific fuel consumption. What is the unit of the specific fuel consumption? Kg per kilowatt. Because MF is in kg per hour and Vp is in kilo. So that's why this is the unit. So next one is about the efficiency. The first efficiency is indicated thermal efficiency. Okay. So what is this indicated thermal efficiency? It is the ratio of Ip by, that is indicated power by power generated. Okay. Okay. Mass of fuel into calorific. So this is a formula to find out the power generated or power produced. So next one, brake thermal efficiency. It is a ratio of brake power to the power generated. Next one, mechanical efficiency. It is the ratio of brake power to the indicated power. That's all. I hope you understood. Please check it.